So we'll go to the next problem. So the question is same here. Determine the resultant and its inclination for the system shown. Find moment about point A. This is point A. Also find the intercepts. Okay. To find, we need to find resultant, its inclination, moment about point A, and intercept. That means we need to find summation fy, summation fx, r, theta, and then moment about point A and x, d, and y. Okay. So you can see here, this is a square A, B, C, D. The side is 1 meter. 1 meter from A to B, B to C 1 meter, C to D also 1 meter, and D to A also 1 meter. It's a complete square of side 1 meter. Now there are 4 forces at point A. 100 kilonewton is acting. It is acting vertically downwards, or you can say along negative y axis. Okay. Now at point D, 200 kilonewton is acting. It is acting at an angle 30 degree with horizontal. Now you can see where 200 Newton is acting. It is acting in first quadrant. Okay, you can see here it is from this at this point, or you can show this point. Imagine a quadrant. If you imagine a quadrant, it is acting in the first quadrant. Now at point C, 100 kilonewton is acting. It is acting purely along positive x-axis, and this 200 kilonewton is acting in the third quadrant. Angle is 45 degree with horizontal. So now we'll begin with the problem. So I have redrawn this figure. Now I have redrawn this figure. You can see here. This is a given figure now. Yeah. Now this is point A, this is point D, this is point C, this is point B. At point A, 100 kilonewton is acting vertical downwards, so 100 kilonewton is acting vertically downwards. At point B, 200 kilonewton is acting in the third quadrant. So we know that in third quadrant, this is the x component, this is the y component, right? So if you remember, this is the third quadrant, this is x component, this is y component. So you can see here, angle is 45 with respect to x-axis. That means x component is cos, y component is sin. So this is 200 cos 45 and this is 200 sin 45, right? And at point C, 100 at point D, at point C, at point B, and at point A. Totally there are 4 forces. 100 acting vertically downwards, 200 acting in the first quadrant. So these are the components: 200 sin 30, 200 cos 30. 100 is acting purely along positive x-axis, and here it is 200 acting in the third quadrant. So 200 cos 45 is x component, 200 sin 45 is the y component. Okay. So first summation fx. First we'll write summation fx is equal to, summation fx means addition of x component of all the forces. So 100 Newton is acting purely along y axis, there is no x component. Now here will come, here it is 200 cos 30, so acting along positive x axis, so plus 200 cos 30. 200 sin 30 is acting along y axis, there is no x component. Now it is 100 kilonewton. 100 kilonewton is acting along purely along x axis, so plus 100. Now this is 200 and in the third quadrant, so x component is 200 cos 45. So it is minus 200 cos 45. So 200 cos 30 plus 100 minus 200 cos 45. This is summation fx. On the similar note, summation fy is equal to minus 100 acting vertical downwards, minus 100. So it is 200 in the first quadrant. So it is 200 sin 30. So acting along in the first quadrant, y component is positive. So plus 200 sin 30. 100 acting purely along x-axis, there is no y component, and here you can see 200 Newton is acting in the third quadrant. In the third quadrant, y component is negative. So first we'll put negative sign here. What is the component? The component is 200 sin 45. So it is 200 sin 45. That's equal to. Okay. So this is summation fx 131.78. This is summation fy minus 141.42 kilonewton. Now we know the formula. R is equal to under root summation fx square plus summation fy square. So under root 131.78 square plus 141.42 square. Square root of answer is 193.30. So the answer is 193.30 kilonewtons. And theta is equal to tan inverse summation fy by summation fx. Shift tan inverse. Consider only sign. 141.42 divided by 131.78. It is 47 degree. Okay, so this is R, this is theta. Now we need to find moment about point A. Okay, so moment about point A, or you can say summation of moment about point A is equal to. So first see here. Okay, so moment about point A is equal to, so we are considering moment about point A. Okay, so what is the moment? Moment is force into perpendicular distance. We need to consider each force and multiply it by its respective perpendicular distance to point A. Okay, so first if you consider 100 Newton force, so 100 Newton force is acting exactly at point A. Okay, so moment produced by that force on this point is 0. Okay, because we know that if the force or its line of action passing through the given point, then the moment produced by that force on that point is 0, and there is no perpendicular distance because moment produced is 0. Okay, now moment produced by 200 cos 30 at point A is how much again? So again, if you consider here, so if you produce a line of action backwards, it is passing through the given point. So moment produced by 200 cos 30 on this point is 0. Now we'll consider 200 sin 30 force. Now 200 sin 30 into the perpendicular distance. So force is vertical, distance should be horizontal. You can see here it is acting here. So 200 sin 30 into 1 meter. It is clockwise or anti-clockwise? From this point to this point along the distance, imagine an arc. So it is anti-clockwise, right? So minus 200 sin 30 into 1. So first I will write here minus 200 sin 30 into 1, right? Next we'll consider this 100 Newton force. So 100 this 100 again force into perpendicular distance. Now this is a force. Now to this point, what is the perpendicular distance? If you produce a line of action backwards here, okay, now you can see here the distance is 1 meter. Force is horizontal, distance should be vertical. Okay, 100 into 1. Now it is clockwise or anti-clockwise? From this point to this point along the distance. Okay, imagine an arc. It is, you can see here it is clockwise. Okay, or you can also assume the force here. Just assume the force here. So this is a arrow mark. So it is acting like this. Okay, it is a plus. It is acting clockwise. So 100 into 1 clockwise. So plus 100 into 1. Okay, next we'll consider 200 cos 45. So again force into perpendicular distance. 200 cos 45 into distance is again 1 meter. If it is clockwise or anti-clockwise, so from this point to this point along the distance, imagine an arc, and here it is completely anti-clockwise. It is anti-clockwise, right? Yeah, it is anti-clockwise. Minus 200 cos 45 into 1. So it is minus 200 cos 45 into 1. Minus 200 cos 45 into 1. Okay, and moment produced by 200 sin 45 force is how much? So it is passing through the given point A. So moment produced by this force on this point is 0. Okay, so summation of moment about point A is equal to, so it is, if you solve this using calculator, it is minus 141.42 kilonewton meter. Okay, now once you got the moment summation of moments, D is equal to summation of moment divided by R. So it is 141.42 divided by value of R is 193, I think. Yeah, it is 193.30. 193.30, and X is equal to summation of moments divided by summation Fy. Summation Fy is 141.42. So it is also minus 141.42, which is equal to 1 meter. And Y is equal to summation of moments is 141.42 divided by summation of X. Summation of X is 131.78. 131.78. So D is equal to 141.42 divided by 193.30. It is 0.73. And X is 1, and Y is 141.42 divided by 131.78. It is 1.07. 0.07 meters. Okay, so this completes the problem. Okay, so we'll see the next question. So you can see here, this is a given figure. The question here is again the same: to determine the resultant moment about point O. This is the given point O. Moment about point O and intercepts. Okay, given the grid size as 10 millimeter by 10 millimeter. Each side is of 10 millimeters. Okay, so we need to find the resultant moment about point O and intercepts. So how to find the resultant? We know the formula, under root summation of x square and summation of y square. That means to find resultant we need summation of x and summation of y. Okay, so before finding the summation of x, summation of y, first let us find the angle theta 1, angle theta 2. Okay, so first we'll find the theta 1. Okay, so tan theta 1, tan theta 1 is equal to, what is the formula? Tan theta is equal to opposite divided by adjacent. Okay, now you can see here it is going like this. This force is going like this here. Okay, so now we'll complete the triangle here. We'll complete this triangle here, right? Okay, now what is the opposite by adjacent? Opposite is 1, 2, 3. Totally 3. That means 10 plus 10 plus 10. That is 30. This is opposite. And what about adjacent? Adjacent is 10. 30 by 10. Theta 1 is equal to tan inverse 3. So theta 1 tan inverse 3, 71.56 degree. So it is 71.56 degree, right? Similarly, tan theta 2 is equal to, I can see here theta 2 is acting like this. Okay, that is, this force is acting like this. This 200 Newton force is acting like this. Now we'll complete the triangle here. Can you see this triangle? We'll complete this triangle. So tan theta 2 is equal to opposite. Opposite is 1, 2, 3, 4. Totally 40. But adjacent is this. That is 10 plus 10. That is 20. So theta 2 is equal to tan inverse 2. So shift 63.43. Okay. Now first we'll write summation of x. Summation of x is addition of x component of all the forces. So first let us consider 100 Newton force. So 100 Newton force is acting in which quadrant? Now you can see here it is acting purely along positive x-axis, right? So we'll write plus 100 here, right? Then we'll consider 150. So 150 is acting again along purely x-axis, that is positive x-axis. Okay, so plus 150. How to know where the force is acting? Just at the starting point or at this point, imagine a quadrant. Imagine a quadrant, then you will understand. Now where 250 is acting? It is acting purely along vertical downward direction or negative y-axis. So its x component is 0. Then we'll come to this 200 Newton force. Now you can see here this 200 Newton force is going like this, right? Now where it is acting? So at this point or at this point, imagine a quadrant. So if you imagine a quadrant here, it is passing through third quadrant but actually acting in the first quadrant. As it is acting at this point, so we'll resolve the force here. So actually it is acting like this. So at this point it is x component, right? Because it is acting in the first quadrant. It is y component. X component is 200 cos theta 2. Theta 2 is 63.43. And this is 200 sin theta 2, right? So x component is how much? X component is 200 cos 63.43 acting in positive x-axis. So plus 200 cos 63.43. Okay, then we'll come to this 400 Newton force. Now this 400, where it is acting? So at this point or this point, imagine a quadrant. If you imagine a quadrant here, actually it is acting in the fourth quadrant. And angle of inclination is how much? You can see if you assume a quadrant here, angle of inclination is theta 1 with respect to horizontal. If this is theta 1, this is theta 1, or you can say this is theta 1. Okay. Now it is acting in the fourth quadrant. In fourth quadrant, x component is positive. So first we'll write positive sign. Theta with respect to horizontal, that means x component is cos. So this is 400 cos theta 1. Theta 1 is 71.56. Okay. Similarly, summation Fy. First we'll consider 100. It is purely acting along horizontal, or you can say positive x-axis. Y component is 0. 150, y component is 0. 250 purely along negative x-axis, negative y-axis. So minus 250. Right. So you can see here for this 200 acting in first quadrant, this is 200 sin theta 2 acting vertically upwards. So plus 200 sin theta 2. Theta 2 is 63.43. And we'll come to 400. So acting in the fourth quadrant, in fourth quadrant y component is negative. First I will put negative sign here. So this is 400, x component is 400 cos theta 1, y is 400 sin theta 1. So this is 400 sin theta 1. Theta 1 is 71.56. This is equal to, okay. So we have considered 100, we have considered 150, we have considered 250, we have considered this 200. Okay, this 200 acting in the first quadrant. So in first quadrant, x and y both are positive. So x is positive, y is also positive, right? This 400 acting in the fourth quadrant. In fourth quadrant, x component is positive. So positive, y component is negative. Okay, now we'll solve this. Okay, so after solving, summation of x is equal to plus 465.98 newtons. Summation of y is minus 450.58 newtons. So r is equal to under root summation of x square plus summation of y square. So summation of x square plus summation of y square under root of answer. We got 648.20. We got the value of r as 648.20 newtons. And theta is equal to tan inverse summation of y by summation of x. So shift tan inverse summation of y is 450.58 divided by 465.98. 44 degrees. Right? 44 degrees. Okay, now we will consider moment about point O. We got the value of summation of x, we got the value of summation of y, we got the value of r, we got the value of theta. Okay, now we'll find moment about point O. So moment about point O. First we'll consider this force, that is 200 Newton force. So there are two components, 200 cos theta, 200 sin theta, or theta 1. Okay, now moment produced by this force at this point is how much? It is 0, because these two forces passing through the given point. Okay, so moment produced by 200 Newton force about point O is 0. Then we'll consider 100 Newton force. So moment produced by 100 Newton force at point O is how much? So if you see here, it is acting like this. So if you produce line of action backwards, it will meet at point O. So if a force or its line of action passing through the given point, then moment produced by that force on that point is 0. Okay, so moment produced by this force is also 0. Now we will go to 150. So again, what is a moment? Moment is force into perpendicular distance. So 150 is acting like this. If you produce a line of action backwards, it is acting actually like this. Moment is acting now here. Okay, the force is acting here. Now moment at point O due to this force is force into perpendicular distance. Now this is the force is acting. So that is 150. Distance is, force is horizontal, distance should be vertical. So force into perpendicular distance. Distance is 10 plus 10 plus 10 plus 10. 150 into 40. You can see here 150 into 40. Right? Clockwise or anti-clockwise. You can see here from this point to this point, imagine an arc along the distance. So if you imagine an arc here, you can see here it is completely clockwise. So plus 150 into 40. Plus 150 into 40. Okay, next will come to 250. So moment produced by 250 Newton force at this point O is how much? Again it is 0, because this force passes through the given point O. Okay, so moment produced by this force at this point is 0. Now we will consider 400 Newton force. So it is acting in the fourth quadrant. So this is x component, right? For fourth quadrant, this is x component and this is your y component. This is 400 cos theta 1. This is 400 sin theta 1. Okay, so moment produced by 400 cos theta 1 at this point is how much? Again it is 0, because this force is passing through the, or its line of action passes through the given point O. Then moment produced by 400 sin theta 1. Okay, so 400 sin theta 1 into distance is force into perpendicular distance. Force is vertical, distance should be horizontal. So this is the distance. This is the distance. So distance is 10 plus 10 plus 10 plus 10. That is 40. 400 sin theta 1 into 40. It is clockwise or anti-clockwise. You can see here from this point to this point along the distance, imagine an arc. So you can see here it is clockwise. So plus 400 sin theta 1 is 71.56 into 40 into 40. So we have considered this 200. So moment produced by this force at this point is 0. 100 is 0. 150 into 40. 250 into 0. And 400 cos theta 1 is 0. Sin theta 1 into 40. Okay. Okay. So if you solve this, we got the value of moment as 21,000. 1 second. We'll solve this. 150 into 40 plus 400 sin 71.56 into 40. 21,178. 21,178.48 Newton millimeters. This is moment at point O. Now D is equal to X is equal to Y is equal to, you know the formula, D is equal to summation of moments divided by R. That is 21178.48 divided by 648.20. It is 32.67 millimeters. 32.67 millimeters. X is 21178 point divided by summation of Y. Summation of Y is 450.58. The answer is 47 millimeters. And similarly, Y intercept is 21178, that is summation of moments divided by 465.98. It is 45.4 millimeters. Okay, so this completes the problem.